If you are applying for a forward-deployed engineer role, the generic toy chatbot on your resume is likely holding you back. Hiring managers prioritize candidates who can handle real enterprise integrations, and a simple chat interface fails to demonstrate that capability. To fix this, we are going to follow a 5-minute roadmap to build one project that mirrors the actual forward-deployed engineering loop. By the end of this process, you will have a live AI agent connected to a real Postgres database, running in a Docker container, and supported by professional-grade documentation. To start, you will need a working knowledge of Python or TypeScript, an active cloud platform account, and the patience to troubleshoot messy integrations. This specific roadmap separates candidates who understand AI theory from those who can actually deploy it to achieve a business outcome. Begin by anchoring your project in a real-world industry vertical, like healthcare, fintech, or logistics. Identify one specific bottleneck where an AI integration would create measurable efficiency. When sourcing your information, avoid the clean data trap. Do not use perfectly formatted Kaggle datasets, as they do not represent the data found in a corporate environment. Instead, scrape or synthetically generate data that is unstructured and chaotic. You want missing fields, inconsistent types, and legacy formatting constraints. In a production environment, the AI model is often the easiest part of the build. The ability to navigate and integrate the difficult 80% of messy data is the skill companies are actively hiring for. Once your data is ready, write the core agentic logic specifically designed to solve that industry bottleneck you identified. While most tutorials stop at the agent logic, an FDE project requires infrastructure. Connect your agent to a live Postgres database rather than a static local file. Next, wire the system to a live external API and configure the necessary authentication. Real-world forward-deployed engineers are integrators. Connecting to live infrastructure proves you can handle the authentication errors and network latency that define production software. Simply stating that a project works is insufficient for an interview at a frontier AI lab. You must build an evaluation harness, or an eval. This is a performance matrix that quantitatively measures your system's accuracy, latency, and success rates. Companies like OpenAI weight a candidate's understanding of evals very heavily, as it is the only way to ensure an agent remains reliable at scale. Creating these tests demonstrates that you can translate a technical feature into a value that a business stakeholder can actually measure. With the testing complete, a project that only runs on your personal laptop is not yet a production-grade system. You must avoid the localhost trap. Use Docker to containerize the entire project and its dependencies into a single, standardized unit. Finally, push that container to a live cloud platform like AWS or GCP to generate a publicly accessible URL. Providing a live link in your application proves to the hiring team that you can successfully ship code into a live customer environment. The technical build is only half the work. Detailed documentation is what often determines whether a hiring manager bothers to look at your code. Your README should feature 2 key sections. First, scoping, where you define the business bottleneck. Second, technical trade-offs, where you justify the specific architectural choices you made during the build. Follow this with a section on debugging, detailing exactly what broke and how you fixed it, and a standardization roadmap for deploying the system to multiple future clients. This documentation structure shows how you prioritize a customer's operational needs alongside the technical code. This architectural loop produces a portfolio piece modeled after the high-stakes deployments found at companies like Palantir or Anthropic. When discussing this project in an interview, lead with the why. Explain the business problem you solved before diving into the technical stack. This framework reflects the forward-deployed engineer's primary responsibility, owning the final outcome. To start constructing your own systems, check the description for structured building programs and cloud credits to help you launch your first container.